Hi everyone. In this tutorial, I'm going to be going through how to use Google Collaboratory to create 2D neural style transfers. So we're going to be looking at the Google Drive folder that I've shared with you all called AI Altered Architect. And we're going to be looking at how do we get this to work with the Google Colab. So the first thing you want to do is you want to navigate to your AI Altered Architect folder in Google Drive. And you see there's a couple of folders. We want to download this download setup folder. So we're going to download this to our computer. So once we've downloaded it, it's a bit counterintuitive, but we're going to want to basically create a folder somewhere in our Google Drive. I'm just going to call mine JL example. And I'm going to want to open up the folder, that download setup that I've just downloaded, and I want to re-upload all these files, folders onto my Google Drive. So, but by the end of this step, what you should have is you should have a folder located in your Google Drive, calling it whatever you want, and then you should have a folder with all files that you've downloaded from the AI Altered Architect folder. So I'll note that within this drive, we also have a master notebook section. These master notebooks are just for in case something happens to your notebooks. Please don't delete them or move them. If something does happen, just you can open them up, and it's best to make a copy onto your drive. So yeah, they're just the clean notebooks that you can start from scratch with if something happens. We've also got a data sets folder, which I'll show you in a bit how to use, and some other things which I'll go into more detail later. So once we have this all uploaded onto our Google Drive, what we're going to want to do is we're going to want to go into our notebooks section, and we're going to want to navigate to this neural transfer file, and we should be able to right click and open with Google Collaboratory. If you can't do that, another way we can do it is if we just Google Colab and then welcome to Collaboratory, and it'll ask you for this immediate pop-up window, and I'll show you what we can do. And I'll leave the link to this GitHub repository in the description of this video. But what we can do is we can basically just copy this and then go GitHub and paste that in here, and it should go and find this repository, and we'll click open from here. That's only if you don't have an option to open with Google Collaboratory. You should have an option. If not, you can also go connect more apps, and I'll pop up this window and search for Google Colab, and it should be installed. I would recommend using your personal email accounts rather than the student email accounts, just so you can streamline everything. So once we have this open, basically this is what Google Collaboratory looks like. So it's basically a notebook where we can run particular machine learning or algorithms over the cloud using Google's cloud service, which is free and which is great. So a couple things, it does have a 12-hour runtime. So if you've been using their cloud computing services for more than 12 hours, it will shut off. That's how Google maintains it to be free. And because this is a free service, you're kind of limited to the GPUs that we can use. So a quick introduction onto neural style transfer. It's quite a well-known AI algorithm where basically you're transferring the style image of one image onto the next image. So in this case, it's taking a photo of Brad Pitt and a painting, and then transferring where the outcome is an image that is of Brad Pitt, but in the kind of style of the painting. So we'll be doing that, but we'll be looking more at how do we use them in architecture for, landscapes and cities, and I'll show you some examples now. In our folder, if you go to neural transfer examples, you can see that there's going to be some examples of the things we're looking for in terms of speculating on different cities and what that might look like. So generally, this neural style transfer is very good for kind of observing style transfers of aerial imagery and then translating between them, which is what we'll generally be working with. So before we get started, there's a couple of things that we need to do for to set up the Google Colab. So what we're going to do first is in the top right hand corner here, we're going to click connect. And that's basically connecting our computer to a cloud GPU in Google's data centers. So once you'll see it starts to initialize, and then you should get a tick that says connected. And we can see here, it's going to tell us that we've connected, and it's going to show us as we start using it how much RAM and GPU we're using. This algorithm is not necessarily that heavy. It does get heavier when you begin to start transferring larger images. So the run times get a bit slower, but generally to start off with, it is pretty quick. So if we just click on this cell, there's a quick explanation of what neural style transfer is, which you can read. Google Colab works a lot like a document editor. We've got a file section we can save a copy, move, etc. And we've got an edit, a view, insert, runtime, which I'll get into, and tools. So that's kind of the basic setup. We can also, if you want to change the editor's font settings in the top right hand corner, we can change all that kind of stuff as well, as you like to visualize it. So then in this left hand bar, you'll see we've got a folder icon. That's probably the most important thing. So the first thing we need to do is mount our Google Drive. And what that means is basically we need to make sure that the notebook is talking to the Google Drive so that we can pass our files to this notebook. So we can point the files in the direction of where they are in our Google Drive so that the algorithm knows which images it wants to choose. So to do that, our first step is if we hover over this first cell where it says step 1 mount drive and we press play, it's just going to quickly ask, and it's going to say permit this notebook to access Google Drive, and you're going to want to select connect. And then it's going to ask you to sign in. In this case, I'm going to sign in, and it's going to ask us to give access, and we're just going to navigate to the bottom and click allow. And once that works, it'll just wait, and you'll know it works when this stops basically running. So it says mounted to drive. And now if we click back on this, you'll see that we have a new folder called drive. So The first thing that's important you'll note is we've got a My Drive and a Shared Drive. So if we click My Drive, it's going to show us all our folders in the drive. So I should note, when you do come to this AI Altered Architect folder, what you want to also do is in the top section here, you want to click on it and do add a shortcut to drive, and you just want to make sure you add a shortcut to your drive. This is because when we start to find the data sets, we want to have it in our My Drive. So I'm just going to refresh this. Hopefully it comes up, and it's just here now. Okay, great. So now that we've mounted the drive, we basically wanted to point to a folder in our Google Drive of where we're going to store all this code. So basically, the way this notebook works is we download a pre-written code from a GitHub repository, and that's all the code that we need to run the algorithm. So we need to point in the Google Drive where this is going to download. So what I'm going to do is I'm going to navigate to that folder that I created, so this JL example folder, and I'm going to point the algorithm to this folder here, this neural transfer, and you should see that it should be empty when you upload it. So to do that, what we do is we go back into our notebook, we navigate to our folder, and we find that neural transfer folder, which is here. You'll see when you hover over it, there's this 3 dots. All we do is we click on that dot and we copy the path. One thing I'll note as well, and we just paste it in here. So we've got %cd and our path to that file. So one thing I'll note is that the Google Drive and Google Colab is quite sensitive to spaces in your titles. So try to either refrain from using spaces like this, where it's just, back to back to back words, no spaces, or use an underscore, because if we put say this Google Colab path, you'll see what happens is it's going to create this kind of situation here where it only reads the path up to here, and then there's a space in a notebook. So we just want to make sure in our titles that there's no spaces. So I'm going to copy that path here. So when we've copied that path, we just press play, and you should know it works when there's a tick and then comes up with showing you that path. So the next thing we want to do is we want to download the algorithm. So we're just going to press play here, and it's going to download the GitHub package. So you'll know that it's worked, because when you navigate back into that folder that you've pointed to, you should see a style transfer folder, and you should see all these files. You don't need to worry too much about what these files are. These are all basically the files that run the algorithm. So then the next thing we need to do is just import all the necessary libraries that are needed for the algorithm to work in terms of the AI components of the algorithm. So you only need to do these first 4 steps once, basically. So we'll just press play here, and that should run the algorithm. So now that we've got the tick, it's all ready to go. We're all set up. So now, once you've done this once, as I've said, you don't need to do that again, because you will always have basically these files in your Google Drive. So that's why it's really important to keep this clean and keep the setup of folder structure clean. So the next thing that we're going to talk about is then the parameters of our style transfer. So we've got a couple parameters. We've got the number of iterations that we do on of the algorithm. We've got the image size. At the moment, this algorithm works best on the same proportions of image. So when the width and the height are the same, generally speaking, when you're just iterating and just testing, 512 probably works the best. When you start to go up to that 1024 or higher range, that's when you'll start to see a bit of a slowing down of the computing of the images, just because it's processing more data in the image and the information stored within the image. So then we also have different content weights and different star weights and variation weights in the image. We've got an input image, which is our just content image, which I'll get into what that is. And then we've got different convolutional layers that we can use within the algorithm, which I'm not going to explain too much of that here, but I've included some links of what convolutional layers are, and there's an explanation here of what these are and what you can choose from. I'll note that within this kind of neural transfer example parameters file in the shared drive, if you navigate to the bottom, there's a couple of kind of parameters that you can see to understand what kind of parameters do what. This is kind of a process of trial and error as you go along and understanding kind of what weights work, what weights don't, what images as style images work, what images as contents work, and you'll understand as you start to run the algorithm. So that's the kind of parameters. And then this next step is you don't necessarily need to change this section here. This is where we change the convolutional layers of the content layers and style layers. So basically what this means is we can tap into which part of the convolutional process that the algorithm is learning from. So the convolutional layers is basically a way that the images are processed and each pixel is identified and learned from in the transfer process. So we can isolate particular layers within this convolutional layer process of the content and style images, of which images, parts of the images that we use to style transfer, basically. So it's a good tip you can read this kind of towards data science explanation of convolutional layers, just for a basic understanding of what they are. And you can have a look at these kind of different parameters and what they do. Generally speaking, the convolutional here works quite well, but we can tinker around them as we go along. So the next thing that we want to do is we want to choose our images. So there's a couple ways we can choose our images. So within the shared drive, I've got a datasets folder, and we've got quite a few different datasets. So we've got images of Mars. We've got images of Mars that are set to 1024 or 512. We've got city images as well. And then we've got a kind of like data set online images where we can go to a place like daily overview. And we can look at, say, we want to look at, let's say, cities. We can navigate to cities and we can find, say, a city of Paris, like the Arc de Triomphe. And then what we can do is we can let's do after triumph aerial view. So we can also find images on Google. So let's say we want something like this image. So we can, if we navigate to this image, we can go open in each tab. So we have the image, and we can actually copy the image straight away. I think that's not a JPEG. Let's try. Let's just try this one. So we can copy that image. And then you'll see here in this section, if we go back to our image selection, we've got a section for content images and a section for style images. So what I'm going to do is I'm going to say arc, just call it arc try, and I'm going to go equals and quotation marks and paste that link into the here. And then what I could also do is I could look at these Mars images, right? And I could say, well, if I go view, let's find one that's kind of, you know, sort of interesting. So maybe something like this, right? So number 6 dupe. So then what I'd want to do is I'd want to go back into my notebook. In my files tab, I'll go to AI Altered Architect, Datasets, Mars Images, and I'll find that 006 dupe image. So just here, and then I can just copy that path, and I can call it, say, here, Mars 006 equals quotation marks, and paste that in there. So now I've got 2 ways of importing an image. We either do it through the web, or we can do it through our Google Drive. So then once we have that here, this is where we define those images. So I'm going to call our content image what we call it. So it's got to match what we've called it here. So you can either just copy and paste it, arc tree, and then we'll copy this one and call Mars 06. So once we've defined the image, that's basically all we have to do. And now if we navigate back up to the top, you'll see where it says to run code each time, select this, and then select run time after selection. So we just select this cell by just clicking on it. We navigate to run time at the top, and then go run after. And what that's going to do, it's going to run all these cells after until we go. So we can see here it's got our content image, our style image. It's going to download our neural network. So this neural network is basically pre-trained on style transfer. So that might take a bit of time to download. And then it should, if we keep navigating down to the bottom, eventually we'll start to see our iterations appear. So we can see here, that's iteration 1. It's starting to show us the different iterations, and we can see here in terms of the graph, it's going to show us the loss of kind of style of the weights that we've chosen of the style, and then the content images, and then the variation between the 2 images. So this one is not that successful. So let's try. And then, so if you ever want to just stop it, you can just click on the cell that's running. So we can just click here and it's going to stop the runtime. So let's go back up and we'll choose some different images. So maybe let's look at this batten image, and let's look at this image here, R1. And so again, we're just going to go up to the top, select this cell, runtime, and after. So we can see here, this is the style image, this is the content image. And it's going to hopefully start to put our image here. So once this finishes, you'll see the final images. They'll appear in this folder that you've set up, and there'll be a combined image once it finishes in here. So just to quickly show you some examples. So when you start to do this, the best way to show these images is having the input and the style and the content, and then showing us the kind of combined image. So here's some good examples of previous work where they're exploring these kind of aerial views. So you can see the good ones occur like this one, where you're matching scales as well as matching sort of aesthetic geometries and languages within the style and content image. So you can see this one is quite interesting because, you know, there's this kind of radial aspect to the initial image, but there's also a radial aspect to the architecture city that this student is choosing. And so then when it's combined, it's this kind of interesting combination where we can read the architectural fabric of the city, but it's in this kind of weird kind of architectural language of the original kind of landscape that was chosen. And then this student has done kind of different iterations of that to understand kind of how this image is implicating cities. So successful ones you'll look at them and think, you know, this could be a city. It kind of blurs the line between a natural formation and architectural city. So some of these ones are also quite interesting, where we can see it's almost giving us this idea of what a kind of densely packed system of living would be along a river. So it's taking a river, it's taking architecture on the river, and you can see the algorithm is picking up the fact that these images have this kind of green river, but then also it's combining the buildings into the periphery of the river. So one thing that's important is really image choice, image scale, and also image kind of the color of images. So you can also, what you can do is if you find that, say you find a really good image, but they're not quite matching color-wise, you can always edit them in Photoshop to see how that might affect the translation. So if we go back now, we can see this is our result. It's not that great because we're only running it on 10 iterations, but as long as you start to run it a bit longer, you should get some interesting results. And then it'll also spit out this image, which you can just right click and save. So that's the basics of how to use the 2D neural style transfer. Um, I've also included a external tutorial on how to use it by this guy on YouTube that uses this same GitHub repository. I'll also include the link to this YouTube tutorial in this document so you can look at it as well. Thanks. See you in the next one.